Hello and welcome to today's video. Today we will be doing a demo of how to flatten a dress. This particular dress was created in Rhino and had a texture applied to it, so we will be doing the flattening, and we will be showing how to flatten a garment and how to use ExactFlat Monarch to create PDF patterns of this that can then be sent to both printers and plotting tables. This model has already been meshed, and in fact it came in as a mesh. So when we look at the layer tree, we've undergone a few different operations here. So the default layer has the original mesh that came in. This is modeled as half a dress. So we've gone ahead and we've mirrored this. We've also cut the mesh in half and joined it together. The final step of the process was to apply a texture to this mesh, and we've already done that. So if we turn on the remeshed layer, we can see our final mesh here has been remeshed and has texture applied to it. So we've already accomplished pretty much all the preparation steps required for ExactFlat. We've used the surfaces to create a mesh, we've cleaned up the mesh, we've applied texture to it, and we've already used the adaptive remesher to clean up the mesh. So all we're left with at this point is the flattening steps. So to begin, we will use the ExactFlat flattener, so as the very first icon in the ExactFlat Tools toolbar, and we're just going to simply rectangle select all the meshes here. Now this particular model does have a lot of pieces on it, so instead of flattening all these pieces separately, what we're going to do is we're going to use the ExactFlat cutting tools to remove some of these cuts. So before we do any kind of pattern processing, before we even use the pre-flatteners to remove our strain and sag, we're going to use the ExactFlat delete cut tool, and we're going to remove some of these cut lines. So we can do this either on the 2D pattern, which is laid out all over the place, or we can use the 3D reference model. So we're just going to select lines here, and we're going to delete some of these cuts on the 3D model. So we're going to create one single piece for the front here. We're going to create a single piece for the back, top half. And what we're going to do, we're getting this tearing or flickering effect, probably because we've got both the rendered mesh and the reference model mesh over top. So we're going to make our model layer, default layer, and we'll turn off our rendered mesh. Now we don't have two meshes occupying the same space. So we're going to continue, we're going to remove some additional cuts here. So we're going to make sure as we remove a cut on the front, we're also going to remove the same cut on the back hand side. And we're just going to join some of these pieces together just so we don't have as many pieces to work with. So we've reduced our piece count just by removing some of these cuts. And now we can proceed to our normal first step with ExactFlat, and we can use the pre-flatteners to remove a bit more of the strain and sag. So right now we're looking at our pattern in rendered viewport, but if we right click on the perspective viewport title, we can change to our different shading modes. So we're going to change to shaded viewport, and now we can have a look at the strain map of these different pattern pieces. So with ExactFlat, it's a two-stage flattener, the first stage being our very quick pre-flatteners, and the second stage being the optimizer. So the biggest difference is the optimizer is always going to give you the final optimized form. However, it does take a lot longer to operate, whereas the first stage pre-flatteners, they are incredibly fast, but depending on the pre-flattener you use, you're always going to get a different pattern. So for this dress and all pattern pieces in general, the best strategy is to simply try different pre-flatteners, and in the case of fracture, it gives the best patterns when used along planes of symmetry. So we're just going to pick different edges along planes of symmetry. Pelt, it doesn't really matter where you choose the piece, you're always going to get more or less the same pattern. But with fracture, we're using fracture because these pattern pieces are symmetrical, so we want to try to preserve the symmetrical shape of the pattern pieces, and we're also using fracture because it tends to give very good results with these shapes here. In the case of these pieces here, just going to drag these away. And even this one up here, we do have some folds and wrinkles or flip triangles. So fracture did not work on these ones. With the pre-flatteners, we can use as many different pre-flatteners as we want, as many times as we want. And in the case of fracture, depending on where we click on the pattern piece, we're going to get a different pattern. So in this case, we're trying different points here to remove the folds and wrinkles, and we're just not able to remove the folds and wrinkles from this piece with fracture. So we're going to try a different pre-flatter on this one. We'll try fracture from different locations on this one here, and again, I don't think we were able to remove all the folds and wrinkles there. So we'll try lastly again up here, and I don't think so. So we're going to try pelt instead. So we'll pelt this piece, and we've got a pattern without any folds or wrinkles, and again over here we've got a pattern without any folds or wrinkles. So fracture is ideal for these because the pieces are fairly symmetrical, and when we use fracture on them, we get patterns with very low strain. So our primary goal for our pre-flatteners is first and foremost to remove any kinds of folds and wrinkles from the pattern. So when we see the cross marks here, I'll just fracture this piece again. When we see these cross marks here, these indicate folds and wrinkles. And if we zoom in even closer on this piece here, we're going to start to see inset triangles. So this is an area of the pattern that has folded or creased on itself. And these are patterning errors that need to be fixed. So our primary goal for the pre-flatteners is to remove these folds and wrinkles. And when one pre-flattener fails to do that, we simply move on. We try a different pre-flattener. So we can try fracture or pelt or CCM, which has 3 different modes. The initial mode tends to work best and give the best results. So if we were to use CCM initial on this one here, we get that kind of pattern shape. CCM initial gives this pattern for this one, and we get this shape over here. So CCM initial and fracture work well on symmetrical pattern pieces, and pelt works fairly well on all of the pattern pieces. The second main goal of the pre-flatteners is to reduce the energy density as close to 0 as possible. So when we look at the pattern pieces, we'll notice that we've got different colors on them. So this one over here has quite a bit of red. We've got some yellow, green, cyan, white, and we're even going into black. So the color shown represents the different quantities of strain or how much the pattern piece needs to stretch. So if we think of the 3D model, so we've got our 3D model over here. If we think of our 3D model as a rigid plastic shell, the amount of strain on the pattern piece indicates how much we're going to have to stretch that pattern to get it to fit back onto the rigid shell. So in the case of this piece up here, this corresponds to the top front piece here. We're going to have to pull this quite a bit to get it to fit on, and that's because the pattern is too small. But this is because we've only used our first stage flattener on it, in this case CCM initial. We haven't optimized these pattern pieces yet. So when we go to optimize these pieces, what ExactFlat's going to do is it's going to add or remove material to give the best fit possible. So before I do that, we're going to turn off our 3D reference model. So we're going to make our pattern the default layer, and we're going to turn off the light bulb to hide the 3D reference model. We're also going to double click on the perspective viewport title. This is going to minimize the viewport, and we're going to double click on top. This is going to maximize the top viewport. So this is going to make it so we have a perfect top-down view of our pattern. Now we're going to go ahead, we're going to optimize the pattern pieces. So we're going to click the spring icon, and we're just going to select all our pattern pieces and optimize them. So for this dress here, we're going to optimize as a simple cotton material. If you have material that you would like to use, ExactFlat does come standard with 85 different sample materials. We also provide a material manager that allows you to create and add your own custom materials within ExactFlat, and we do partner up with a couple different institutions for a very low cost of about $25 US. You can send them a sample of your own material, and usually within about 5 business days they will return the results to you, and you can use those results along with one of our guides to create your own mathematical model for your own material for use within ExactFlat. So we're going to use the default settings here. We're just going to optimize for cotton. The only change I'm going to make is I'm going to turn off our preserve boundaries option. We'll talk a little bit more about this after we optimize our pattern piece and what this particular option does. So we're going to go ahead, we're going to click OK, and we're going to start to optimize. So the first thing we're going to notice as we optimize, we're going to notice that the shape and color of the different pattern pieces is changing. And this is to reflect the material that's being added or removed from the pattern piece. So in the case of the color changing, when it changes from red to more of a white, we're adding additional material. We're reducing the amount of strain on the pattern piece, or the amount that we have to stretch or pull that pattern piece to get it to fit back onto the rigid shell. In the case of the areas where it's black, we're going to be removing material because black indicates sag or an excess of material. So we're going to be removing some of that material to allow the pattern piece to fit onto the 3D model without any kind of excess sagging or wrinkling. So as we optimize our pattern pieces here, we've got quite a bit of information being displayed to us in the spring status dialog. And the most important metric to look at is probably the average energy density. And this is an indicator of how much strain, or the level of average strain across the pattern piece we have. So the closer to zero this value, the closer to a perfect pattern we have. Another important piece of information would be to look at the maximum energy density. So this on its own simply represents the single point of largest energy on the pattern. However, this value on its own isn't the most useful, but you can use this value if you have a very, very high maximum average energy density. That's usually an indicator that you have an error in your pattern. You may have a hole or an undesirable formation of triangles that may have been created as an anomaly, or you could just have if there's a fold or wrinkle or flip triangle when you optimize the pattern piece. A lot of the times that's going to manifest itself as a very large maximum energy density. So on its own, the maximum energy density isn't very useful but to indicate the quality of the pattern, but it is a very good indicator for errors on the pattern that need to be fixed. So if you do have an error, the best thing to do is to either stop the optimize, or you can let it continue running, fix the error, and you just optimize the pattern pieces again. So just like the pre-flatteners, fracture, pelt, and CCM, we can run the optimizer as many times as we want. The most important thing to remember is that any change that's made to the pattern, whether we're pre-flattening or making or deleting cuts, we should always optimize the pattern afterwards to give the best fit possible. So another important piece of information would be our no seam stretch error. So when we consider the 3D model, the perimeter length of the 3D model, and compare it to the perimeter length of the 2D pattern, because we're changing the shape of the pattern, we're adding or removing material, we're also going to be changing the perimeter length of the 2D pattern. And the no seam stretch error is the difference in pattern perimeter length between the 2D pattern and the 3D model. So this is a global measure around the entire perimeter of the pattern piece. So when we consider the size of some of these pattern pieces, and that we're working in millimeters, a no seam stretch error of, in this case we're just finishing the optimization here, about 20 millimeters, that's 2 centimeters. That's a very, very small no seam stretch error when you consider that's global around the entire perimeter. And because of the nature of the material, in this case cotton, it's a fairly stretchy material, that error can very easily be absorbed just through stretching the neighboring pattern piece. However, if you are working with a material that does not stretch, such as leather or metal or plywood, then you really want to try to reduce that no seam stretch error to as close to zero as possible. So when we started our spring or our optimization, we had a look at the spring settings and we turned off the preserve boundaries option. So if we turn that preserve boundaries option on, we can specify a target for no seam stretch error, and this is an additional metric that comes into play during the optimization here, and that option is going to help to minimize this value and bring it down to the target or below. So it's not always going to bring it down to exactly the target. Most of the time it's going to reduce that value greater than the target, but it does a very good job of helping to minimize the difference between the 3D model perimeter length and the 2D pattern perimeter length. So we're looking at this pattern here, and our average energy density is staying fairly constant at about 2.5 Newton meters. The only thing that's really changing is our no seam stretch error, and it's changing very slowly. So in the case where pattern pieces are taking quite a while to optimize, in this case it only took us 1.5 minutes to optimize this piece, but a lot of the times when we observe our pattern, if it's observed to be good enough, or you're just trying to run a quick simulation to see how well it's going to fit, you can click the skip button to skip the current piece, or you can click the stop button to stop optimizing altogether, and ExactFlat's going to accept the results as is. In this case, optimization finished, so we'll click OK, and we'll move on to our next step. So we're going to work with first the front of the dress. So we're going to select this piece here, and to arrange the pattern pieces, we can use simple Rhino commands, and we can also use some of the ExactFlat tools. So what we're going to do first is we're going to move this piece out to the side so we can start working with it, and then we're going to rotate it using the Rhino rotate command. So we're going to choose one of the end points down here as the center of rotation, and we're going to choose the same point on the other side, and we're just going to use this as a reference line to snap this piece so it's perfectly horizontal. So just by holding shift on my keyboard, I'm going to snap my second reference point so it's on the horizontal XY axis. Now, because this piece is perfectly horizontal, I can use the ExactFlat Find tool to start finding the neighboring pattern pieces. So the Find tool allows us to find neighboring pattern pieces, and if I start mousing over the edge here, we can see the neighboring pattern pieces being identified right down here, and we can see the corresponding edge being highlighted as well. And if I select this piece, it's going to move and rotate that piece so it's perfectly aligned with the selection edge. We do have an optional offset, so right now it's set to 5 millimeters. I'm going to change this to about 20 millimeters so we have a bit more of a gap there, and when I run the tool again we can refine the piece. And it's going to change this to about 40 to create a bit more of a gap here. So we'll go ahead and we'll find all the neighboring pattern pieces for the front, and then we'll go on to do the back. So what we're going to do is we're going to repeat the process. I'm just going to rotate this piece. I'm going to select my first rotation center here, my first reference point here, and then I'm just going to hold shift to snap my second reference point to the horizontal x-axis. Now I can use the ExactFlat Find tool to find and arrange all of the neighboring pattern pieces. So at this point, we've flattened our pattern, and we've been working mostly in our rendered viewport, but if we switch back to our shaded viewport, but if we switch back to our rendered viewport, we can see that the texture has flowed, it's followed us all the way through the flattening process, and as we optimize our pattern pieces, the texture actually expands and contracts as well. So when we start comparing our pattern pieces, we can see that the texture flows seamlessly all the way through. So we don't lose any of the texturing through the flattening process. It's followed all the way through, and depending on how your model was textured, if it's textured seamlessly in the 3D model, when you flatten your 2D pattern pieces, the texture is also going to be seamless all the way to the 2D pattern pieces. So from here, depending on your process, we have a couple options. We can either save this file as a DXF right now for use in other patterning applications. So if you're using something like Gerber AccuMark or Optitex to do your patterning work, you can create a DXF and you can proceed with your normal workflow. Or you can use the ExactFlat tools to add additional patterning information. So the easiest tools to use are probably our notch tools, and when we open them up, we're presented with the notch tag default. So we can create different types of notches with ExactFlat. So we have the option to choose between slit notches and V notches. We can change the color of the notch, and we can also change the text tag or the notch name that's going to be created along with this notch. So by default, the %n identifier just simply adds a unique auto-incrementing number. So with the tag that I have here, we're always going to have a unique tag. We can also specify the notch length, and in the case of V notches, we can adjust the notch width as well. When using a length of 0, the notch length is just going to automatically inherit the length of the seam that's being applied. So when we export our DXF or render to a PDF, our notch is always going to travel the entire length of the seam offset. So we're going to go ahead, we're going to click the Add button, and we're going to start to add some notches. So we're going to notice that as we select one point here, a notch is also being added to the neighboring piece on the neighboring side here. So as I start adding all my notches, we're automatically adding notches to both sides of the seams, which makes it very easy to add notches with ExactFlat. Once we've finished adding notches, we can go ahead and we can either create a DXF if we're sending this to a cutting table, and we can do this using the ExactFlat DXF exporter. And this tool differs from simply saving your part as a DXF in the sense that when we create a DXF using the ExactFlat DXF exporter, we're creating a DXF that has both our seam line and cut line, as well as any kind of notches that we've added. If we'd added any other kind of markup to the pattern, then that information is also created in the DXF as well. So we'll go ahead, we'll create a DXF. We're just going to call it dress. And if we import this DXF back into our Rhino workspace here, we can have a look at the DXF structures. So we'll open this up, we'll import it back in here, and we can see the DXF pattern pieces. So once we've imported this, we have all the layers for the DXF in our document now. So we can see we have a grain layer, which is always going to be the horizontal x-axis unless we've added a manual grain line using the ExactFlat grain line tool. So using this tool, we can customize the orientation of the grain line. We also have our cut layer. So when we look at the pattern piece here, if we drag this one over here, it's going to correspond to this pattern piece here. The interior blue line corresponds to the natural perimeter of the pattern piece, and the red line is always going to be the perimeter of the pattern piece plus an optional seam allowance. So this is set in the ExactFlat options panel. So we've got our cut line, we've got our seam line, and in the case of these pieces over here, we also have our notches that we've added. And if we zoom in, we can see the unique tags that are created. So that one is notch 0, we have notch 1, and following this along, we have notch 2, and so on. So all of this information is placed onto separate layers. So in the case of bringing this into, if we're sending this out to a cutter, if we're using, for instance, an Eastman cutter, we will be importing this into Eastman Easy Cut. And at that point, we have the option to assign different tools to the different layers. So we might assign a wheel blade to the cut layer. We might assign a pen tool to the seam layer. That way we can help out the sewing staff by identifying where the sew lines are. We may assign a drag blade to the notch layer to do the slit notches. And we may assign a pen tool, or we may just discard the notch tag layer. If we're going into, for instance, the AccuMark, then we can control the import of the pattern using the AccuMark software to help identify the different features of the pattern simply by creating your proper import profile. We can also, because these are textured and we want to be printing these, we can also render these and create PDFs of the pattern using our ExactFlat Monarch tool. So if we use the Monarch render command, we can now select our pattern pieces here. I'm only going to select 3 of them. And we can actually create a PDF. So depending on the printer that you're using, the material you're printing to, you're going to want to pay special attention to your resolution. Certain materials tend to bleed the ink a lot more than others, so you want to do some tests to make sure that you have the correct resolution set. Otherwise, your printed pattern is just going to bleed out in the material. But for this demo, we're going to render at 150 dpi. We're not going to make any kind of changes to the texture here. We do have the option, we can convert the texture to grayscale or even black and white depending on what Monarch is being used for. In this case, because we're printing a full color image as a garment, we're not going to make any kind of conversion to the texture. Lastly, we can choose which pieces of information are going to be added to the PDF. So when we create our PDF, we're going to add our cut line, we're going to add our seam line, and we're also going to add our notches and our notch tags to the PDF as well. So we'll go ahead and we'll click the render button and we'll render these pattern pieces here. So rendering doesn't take long, and as we render, we can see a live preview being generated and added to the document here. So we'll go ahead and we'll remove those. And if we open up our PDFs, we'll have a look at the structure here. So when we open up our PDF, we can see that we've got both the rendered image here, and again, this is all placed onto different layers. So we've got our print layer here that has the rendered image. We have our cut layer, which is going to be the red line, so we can assign that to a different tool depending on the hardware that you're using. You may have a combination cutter plotter, so we can assign the cut layer to a cutting tool. We could assign the seam layer to we can either turn that off, ignore it, or we can assign that to a pen tool. And we've also got our notch and tags layer. So our notches, again, can be assigned to a cutting tool, and depending on your needs, our tags could be assigned to a pen tool, or they can simply be turned off. But in the case of Monarch, we have the ability to turn on and off the various bits of information that are going to be placed into the DXF. So really, it's best to configure your Monarch export profile to only give you the information that you need. So thank you very much for watching.